The moment you've all been waiting for, CADimensions Morning Show number 2. It's Friday morning. We're closing in on Christmas on the CADimensions Morning Show.
Yeah.
I don't think it gets much better than that, does it, Kevin?
Not at all.
All right, cool. We've got a pretty cool show for you, I think, today. I think every host probably says that, right? Yeah, we've got a great show for you tonight, but we actually do. We have some really cool stuff. I can feel time squandering away already. So this show we kind of set up so that we can, so here at CADimensions, we can kind of hang out with you guys, our customers, our loyal CADimensionites, and get some time hanging out with you. Hopefully share some stuff and get some, feedback from you guys as well. So don't be afraid to use the questions and comments section. We'll be keeping an eye on that as we go. We've got some content to go through, and like I said, give us a shout back in. Let's take a look at what we're going to run through in this show. So to start off, Kevin and I, when we were setting up for this, we decided to go through a couple of underutilized tools. And underutilized tools is kind of a cool topic. It's actually one of my favorites, probably, because it's not even so much about knowing where the tools are, but actually using them. There's a lot of stuff in SOLIDWORKS that I know is there, and it slips in my mind to ever use it. The S key is one of those things. It's been in there for a while, and I just never got around to using it until probably 6 months ago. And these things are really great time savers, I think. So that's going to be a cool topic there. So the first two bullets are underutilized tools. After that, we have actually a special guest, and I think this should be pretty fun. I don't want to ruin any surprises before we get there, but we do have a special guest that will be showing up and talking with us a little bit. And then we have just a brief tips and tricks section, just a couple of tips and tricks that Kevin and I have come up with, little things that you may or may not have come up with. And then at the end, we've got kind of a product spotlight. There's a couple of things that Kevin and I saw when we were going, along the past couple of months that we thought were kind of cool, and we want to share with you guys. So we'll share those with you at that point. And of course, once we get to the end Q&A, we've always got questions that you guys have. We'll take a look at those. So I guess without further ado, we can get going. So we'll start off with the underutilized tools section. And one of the things that I thought of when we were talking about the underutilized tools is actually Rapid Sketch. And Rapid Sketch has been in there for ever. I don't even remember when it actually was added, but it's a pretty cool little tool that actually can be pretty useful. The example that I have here is the idler arm. I think we're all pretty familiar with this part. It gets around. But it is a really cool model. But I've kind of chosen it because I have left out a couple of the features that are in here for this model. You may remember there's a circular cut that goes on these sections, but all three are different planar faces. And Rapid Sketch is a cool one because what it lets you do is actually create multiple sketches kind of on the fly as you're going, which is kind of neat. So for example, if I turn on Rapid Sketch, I can just grab a sketch tool, and as soon as I do that, when I hover over those faces, what it does is it uses that face, as long as it's a planar face, as a face that I can sketch on. So for example, I can come up here and I can create a circle here. And at this point, of course, we can add in relations, whatever we want to do with that, lock that to the center. We can dimension this out, whatever this happens to be, 20. And we can just keep going, right? I can grab another sketch tool and I can just keep creating these sketches. And what it's actually doing is it's creating each different sketches for on those planes, as if I had gone in, started a sketch on that face, and then exited the sketch tool and started a new one. So kind of a time-saving tip here. I don't know what these sizes are. I'm just kind of making these up on the fly. But we can see that this sketch is now grayed out. I'm now editing this sketch, and I can just kind of keep ratcheting my way around here. Picks up this plane. I can draw on this plane. Again, set this to whatever I need these to be. Again, with the S key that I just mentioned there. Drop that down. Again, I'm not sure what the dimensions are, but it doesn't matter. So we can see that in my tree, I've added in 3 new sketches without having to go in, out, in, out, in, out. And I can then again, of course, use these to use whatever I'm trying to go for. Right? Maybe a through all cut here. We'll accept that. So I can just kind of quickly ratchet through these things and not really worry too much about starting and ending sketches. Not that it's a huge hassle, but it definitely speeds things up to be able to create multiple things on the fly. we always talk, in our classes about kind of thinking ahead as you're drawing things, right? So trying to plan and plot for a few minutes before you get to an actual part as to what you're going to do with it before you get there. This is a great tool to use if you've got that in mind, because I know, all right, I got to make these 3 features. I might as well make the sketches for them all at the same time, and then just run through, kind of sweep through them all at once, and get those all set. So kind of a cool tool. I don't see a lot of people using it, and I kind of thought it fit the underutilized tool section.
Absolutely.
Kevin, you want to take a look at
Sure.
another one? Switch you over here.
So this one is kind of near and dear to my heart. Get switched over here. I've kind of been touting this one for quite a while. I see people struggle all the time to analyze assemblies and different information within their assemblies, and we go to all sorts of different spots to do that. If I'm worried about which components are excluded on the bill of material, I can't really see it on the bill of material. I got to search the feature tree for it. If I'm trying to figure out which components have been updated to the latest release, well, I've got some different tools to do that. And there's really not one spot to get a whole bunch of different stuff accomplished. So what I'm going to introduce, and hopefully you're familiar with what it is and what it does, but inside the Assembly Evaluate tab on the Command Manager, also under the Tools pull-down menu, you'll find a command called Assembly Visualization. Right. You can see I've already got mine hotkeyed because I use it all the time. But Assembly Visualization is a completely different way, first, of getting access to the commands for a component, but also visualizing what's happening within that assembly. Now I'm just going to kind of spread this out a little bit just to show you some of the defaults. What we're looking at is a different way of viewing the components in the tree. Now you can kind of see that these are doubled up simply because there's multiple quantities of those. It could be in sub-assemblies. It's kind of reorganized, but I can ungroup those to kind of show a little bit more of a flat list of what's going on each component. I have the ability to give an assembly view, so any sub-assemblies will be indented. But what is this kind of really presenting to me? But it allows us to evaluate different quantities. Now that could be a lot of different things in this case. By default, I have it set up to evaluate the mass of components. And I'm just going to actually go to component view here. So you can see how the mass varies throughout the individual components. But even better than that, we can use this little color bar off to the left to go ahead and add color so I can see that variation that we have here. Now, I'm not going to remember this, right? I've just looked at, okay, what's has the most wet mass, which has the least. And I'm not going to bounce back the assembly visualization every time. I have the ability in here to actually add a display state. So what happens is I now have a display state with all those colors added. I can bounce back and forth to look at the values that I've provided. Now this is pretty cool. We don't, how often you're looking at mass, maybe if you're looking at different materials, but overall maybe not so much. But let's think of some other things that we usually do. How many times you said, "Oh, did I remember to apply a material in my assembly because I'm trying to get a mass at the upper level. I'm trying to get an idea of what this thing's going to do." Well, we can add columns to the assembly visualization tree, or adjust existing columns. In this case, I'm just going to adjust the existing column. A couple things to point out: we can use formulas to do calculations within this, but I have access to a ton of different things inside of SOLIDWORKS. Now I'm going to show you a bunch of these today, but let's start out with SOLIDWORKS material. I'm actually evaluating whether or not material has been applied, but even better, what I would traditionally have to do, right, is go to the feature tree and apply the material. Watch this. You can actually go right in here, get to your material list, edit the material, and apply it directly here. That's the great thing about this assembly visualization is all these things that I'm looking at, I can have some interaction with it. It's not static. And notice that if I right-click on the components here, it's just like right-clicking on the feature tree. Right? I can get access to opening the components and doing other things. So let's take a look at some of the other tools that you might utilize in here. One is your SOLIDWORKS rebuild time. You're worried that your assembly maybe is a little slow, you don't know which component is causing the issue, so you pull up the rebuild time and you can see, oh, you know what, this particular component, this cap screw is slowing the system down. You open it up, can I simplify it, can I do something? Speed up your assembly rebuild time by doing this. A couple other ones that I like to point out. We all know that if your files aren't converted to the current version of SOLIDWORKS, that it makes it a little bit slower. And let me just find it in here, converted to current version. Not seen right here. Okay, this can actually tell you if it's been converted to the 2014 release or it's 2013. If it's not, it could be slower on open and could affect you down the road. I also mentioned the excluded from BOM. That's in here as well. Excluded from BOM tells you whether or not you've excluded the individual component from the bill of materials. The only other way to find that is to go through each component and find out if that checkbox is on. Because once it disappears from the bill of material, it's gone. And then one of the, I think, my favorite, because I think there's no better way to get access to this, but just custom properties. You know, we need to fill out certain data for title blocks and bill of materials. Well, I can come in here and report on the description of it all, but even better, I can fill out the description here just by clicking in the cell and typing in the data. And this goes directly back to the part, just like it would in a bill of materials. Now, one of the things that I think is important if you're going to take advantage of this, because you're probably going to set up different columns and do different things as far as what you report on, you have the ability with this to save styles. So if I'm reporting on like part number, description, just make sure they're all filled out, I save that as a style so that I can turn it on and always see those. If I'm looking at rebuild times and triangle sets, there's a bunch of stuff for performance in there as well. But it allows me to save a style so I can go right back to it. So, I don't know. I would say that's an underutilized tool.
I would definitely agree with that.
All right.
That's one that's even underutilized by myself sometimes. I use it for a couple of things and I forget, how much more it really has.
I think that's a lot of these tools that you get. They're there. You know how useful they are. It's just training yourself to use them. All right. I'm going to go ahead and flip it back to you here.
Cool. Excellent. So I think at this point I would like to introduce our special guest, and our guest today is going to be Bill Green. He's from the U of R, and he's with the SAE Baja team. He's going to talk to us a little bit about their team, about how they're using SOLIDWORKS to set up their car for this season. So Bill, you still on the line there?
All right. Hello, guys. Well, I've already been introduced. My name is Bill, and I'm working on the University of Rochester's Baja SAE team. It's great to be here today, guys. Thank you for having me.
Absolutely. Thanks for coming on. Can you flip on your webcam there, Bill?
Oh, sure. All right. So I'm sitting here in our shop right now, and behind me is our roll cage. So we're currently in the process of building an entirely new one this year. The turnaround process on our cars is pretty quick. We have to build a new one every year. So I guess I'll tell you guys a little bit about what Baja is. Every year we build an entirely new car from our previous design, and we race it at a competition. Now it's a power limited off-road competition, so we only have 10 horsepower to work with, and that's about what you'd expect from a ride-on lawnmower. But to be fair, these things go about 35, 40 miles an hour. So, you have some pristine engineering around that engine to get these cars going so fast. And I think it's exhilarating to work on an engineering team that tries to squeeze every ounce of performance out of something like that. So, I've got a car to show you guys today. And if I bring my screen up, I can actually show you guys a few renders of what we've been doing. So we have been doing a full dedicated design season this year for the first semester. And it's the first time that we've had the chance to do something like that. Everything used to just sort of be a rolling process. But now we've taken the time to step back and do the design beforehand. So as a result, here's what we've come up with after a semester of work. And you can rotate this around. And you can see that it's still not entirely finished, but we did reach a good stopping point before our finals this year. And pretty much all of the design is done. We've just got to make it look a little better for the competition. So the way that we designed this car is we split up into 6 teams. We have frame team, electronics, drivetrain, suspension, composites, and I'm the usability team lead. And we all have different parts of the car that we're responsible for. 2 of the major systems that I work with are the steering wheel, the steering system and geometry, the brakes, and overall the ergonomics of the cockpit. So it's really interesting trying to coordinate with 5 other people about designs that all have to interlap. And SolidWorks is a great way to do it, certainly. When you have an assembly like this that can just fit together piece by piece, you can see how everything fits together if there's any interference. And certainly it's definitely a pleasure to be able to work with something that, there's been more than one time that we've run into 2 parts that are less than 1/10 of an inch from colliding, and there would just be no other way to know that unless we had gone through the trouble to build this car in SolidWorks. So there's a few specific parts that I want to show you guys. One of my favorites is the gearbox, and I have our gear case right here in my hands. This is first iteration moving off of a sprocket-driven car. And this year, our drivetrain lead webbed the gears. So here is a quick video of that working. So we've got everything modeled. We have all the gears webbed. And SolidWorks works great for those means because we're able to take a part that is that complicated and directly put the drawings on paper. Because we outsource the gears, we don't have the broaching equipment to do this ourselves. So we've got to make a professional-looking drawing that can tell someone else exactly how we need to make this. So we're very much in the game of acting like professional engineers, and I think that from a student-driven team for something that's entirely a volunteer association, it's incredible to be able to get this kind of experience so quickly. So I think that people lose sight on the team of what this is really about, because the entire year you're just building this car, you're working on your designs, you're trying to get this and that done, but it isn't until you really get to competition that you realize what it's about. Because as soon as you show up there, you're competing. You're facing your car off against someone else. It's your design, your driver, your everything, and it's just every ounce of your will that you put into this thing to try and be better than everyone else. So we've really seen that after members go to competition, they take that to heart and really put a lot more into the team. So this year, we went to a competition unofficially called Midnight Mayhem. And that was put on by people over in Louisville. And they were able to host a couple of teams for a full race. So what we had our freshmen and our new members do was we have 2 older cars that have been in storage. And they put all the work into fixing them up for these competitions, and they actually got to race them there. And the only thing you really remember about competitions is how little you sleep, but it definitely was a great time. Everyone enjoyed themselves, and we've certainly seen higher member retention because of that this year. Some of the freshmen are putting in just as many hours as we are at this point, and it's exciting to see people so enthusiastic about something like that. And mind you, that a lot of people on our team aren't even mechanical engineers. For example, the person who redesigns the rear bracing this year, which is this part that we're welding right now, is a biomedical engineer. So we like to think of ourselves as interdisciplinary, but really we just rope in people from all sorts of trades. So I've got another picture of one of the days where we were working on all our cars, and it's nice while the weather's nice, but it doesn't last long in Rochester. So we like to bring the cars out in the sunlight while we can. And so I actually have a couple of videos from Midnight Mayhem. I don't know how well they'll play over the webinar, but I'd like to show you guys just what this race looks like. And you can see that it's this massive event. You're competing against hundreds of colleges here, and you're all trying to do the same thing. You're all trying to build this car and make it go faster than the other one. But everyone has a different approach to it, and there's so much that you can do with the design of an entire car that one of my favorite parts about going to the competitions is being able to ask people how they approach the same problems that I'm trying to. Here's another one of just cars racing, and it really is exciting. Some of these things are very speedy, very professionally engineered, and you just wouldn't. It's not something that you would normally expect students to be able to put the time into, but we find the chance to do it, and we come out with wonderful vehicles every year.
That is so cool.
So that's our car passing just now.
Mm-hmm.
And that competition was wonderful. It's great to get in touch with the community. Very nice people, all common interests, and there's really no other way to describe the dynamic that comes from bringing a group of people together to put their love into a car like this. Because you all want to see it succeed. You all want each other's designs to do well, and you'll very much get behind the other person and help them as much as possible to try and, because you're all sharing that same dream that you want to make a reality at the end of the year. And it's only going to come together if you really put your heart into it. So, I mean, I have no problem treating this like a full-time job because everyone else does too. And we all come to expect it from each other. And I don't think that there's any other way to get an experience like this because you are every part of the manufacturing and design process. You know, the first semester, we designed the car in SolidWorks. Second semester, we machined the entire thing. So there really isn't any other way to get a broad perspective on just how much goes into the entire process. I mean, we're managing the team, we're building the car, we're designing it, we're presenting it, we're racing it, and it's all on us. If we don't get it done, no one will. So we very much take that responsibility to heart. And it's just been a wonderful first semester designing the car. I suppose that I can show you guys a few more renders of what SolidWorks has let us do. And it truly is wonderful that we have the ability to be able to see all of this. So this is an assembly of the front wheel hub. And there's a couple of parts that go into this. There's the uprights, there's the brake calipers, the rotors, and we have to package all of that into the hub. So it's a very compact part, and you can actually see that there's a lot that you need to fit into it. There's a lot. The upright controls all of the suspension and steering geometry for the vehicle. So in a lot of ways, it definitely is the most important part, and it's all custom machined. So we're getting the experience knowing that it's a makeable part, because one of the simplest things you can do with SolidWorks is you can make literally anything that you want. Any geometry that you can dream up is possible. But of course, once you get on a mill or a lathe, it just isn't. So, one of the things that we went through with our upright this year is how are we going to make it? And it went through quite a few design iterations before we got to something that was possible to CNC. So that was a rotated view of our wheel hub. And I'll go back to a good view of our upright. And you can see right here our upright from last year. So it's very much an iterative process. We took this, we learned from the mistakes, we thought about how long it took to make, what could make it better, how we make it lighter, what suspension geometry we can tweak to make this thing thinner. And it's really cool when you are on this project for the first year because you're picking up from where someone else left off. You've got to think how you can take something that you've just seen and make it better. And it's exciting to see so much talent on the team in that respect, especially when it comes to SolidWorks and design. One of our freshmen this year has been doing it since high school. And you can see over on the right side in this screen the brake caliper for the vehicle. I just want to hold up the actual part, and you can see the detail and attention that was put into this. And she got pretty much every dimension right. And it's wonderful to see people that are willing to put their time into this on the weekends. And I bring this over. These are some other parts, the brake rotor and hub now. So I think that is definitely the hardest part about using SolidWorks, is taking parts that are aftermarket and throwing them in there. But it still is another part of the design process to be able to put a part on a table and figure out how you're going to throw it in SolidWorks and just reverse engineer it, even down to just measuring the thing. And the only way that this is all possible is that obviously it takes a lot of money to build a car every year, and we're very thankful to the people that are willing to sponsor us for this. And I guess I'll put this back up. Gleason Works in Rochester is a company that builds our gears every year, and without that we just wouldn't have the machinery to build the car that we're building. But I would say that the biggest design challenge overall is trying to take our model and actually manufacture it. And I think that's the most crucial part of the learning experience too. But there are some limitations. We're a rising team. We're very quickly trying to acquire the resources we need to build a professional vehicle. But I'll give you an example. This frame is toleranced to plus minus an entire inch. So that is an extremely poor tolerance, but we still find a way to work around it and build a decent frame every year. But we're always in need of more tooling, more equipment, and we love communicating with companies. I love building relationships with people in the industry, just like Jesse at CADimensions. They were very generous earlier this year to be able to sponsor us for some training, and without that, certainly I don't think that this car would have been fully possible. And it's just wonderful to think that there are people who are willing to lend a hand in getting us dirty in this thing called engineering, because it's all self-taught. This is not something that we do for our classes. This is something that we do on the weekends and in our spare time, because we want to turn ourselves into practicing competent engineers. So it's very good, and there's a lot that comes out of communicating with a company like that. There's professional advice. There's definitely the sponsorship, but we're always looking for people that are willing to lend us a hand with that. So I'd like to just give out a shout out to our team and say that we're always looking for people that are willing to sponsor us. And if you want more information, you can visit us on our website at www.me.rochester.edu/tilde-baja/. And I suppose I'll post that link up in the chat window. But you can take a look at our website. There's a lot of pictures of competitions over the years. It's very, very exciting to see this team evolve over the years. I certainly take a look through the pictures every now and again myself. And it's companies like CADimensions and Gleason and anyone else who's going to lend us a hand that makes this possible. So I ask you guys to come take a look at our website, come see what we're doing, and come see why the Baja is a reason that there are still students graduating with practical engineering experience. So that's pretty much all I've got for you guys today. Thank you for having me. It's definitely been a pleasure. I mean, I think you can tell that there's so much passion that goes into this club. It never stops. It really never does. My friend Berto is machining an output shaft during finals week, and it's definitely worth it at the end of the day. But it takes so much out of you that there's really nothing else you can do except fall in love with it.
Absolutely. Well, thanks so much, Bill, for coming on, and you've got all of CADimensions rooting for you right from the top down, from Pete all the way down. So thanks so much for coming on and talking a little bit about your team and about SolidWorks, and we'll be in touch, I'm sure.
And
All
Bill,
right. Thank you. It's great to have some fans.
we may help you make some connections as well. We have some suggestions on our question section of how our customers might be able to help you. So we may try to connect you with a few of them as well.
All right, certainly. Well, you can get in touch with me personally if you send me an email. I'll also post my email in the chat window. Or you can get in touch with our president, Nick Brown, and I can give you information regarding that as well. We have an entire packet that outlines what we do, what our budget is, what we're still in need of, parts for the car, what our goals are for our long-term 5 years from now. I mean, obviously we hope that we can win, but more than that, along the way, we're just trying to turn everyone into the best engineer they can be.
Absolutely. All right. Well, thanks so much, Bill.
All right. Thank you for having me.
It's our pleasure.
All right.
Pretty cool.
Follow that up.
Yeah, right. That is definitely a neat program. The SAE team has done a great job setting up those things too. The Bahan, the formula, they're so cool. I've been able to take part in a couple of those myself, so it's pretty neat.
Great.
All right, shall we take a look at some tips and tricks? I think we have a tip and trick.
This is always exciting.
Yeah, tips and tricks are always pretty cool. So the first one that I want to talk about also has to do with sketching. And what I'll do here is I'll just drop in a center line. I'm not too concerned about size right now. Let's dynamic mirror this. There's a underutilized tool in itself, I think. Dynamic mirror is a cool one. So what I'm going to do is just lay down a sketch here. Let's make it Christmas tree, why not? All right, so dynamic mirror is neat in that it gives us the ability to set down a sketch that already has relations built into it, or it's already got the symmetric relations built into it, which is cool. But the tip that I want to talk about is just kind of moving sketches around. And sometimes with sketches being partially defined or underdefined, it's tough to kind of slide things around, right? If I want to take this whole sketch, if I grab this and try to slide this off somewhere, right, it just kind of warps, and it's sometimes hard to move things around. Well, there's a couple of ways that you can handle that, and one of the little-known ways, I think anyway, is actually by using the control key. A lot of us are familiar with being able to copy some sketch geometry, right? If we grab a group of entities here, I hold control on my keyboard, I can control and drag that and duplicate it. Just kind of Windows functionality. We can do that, all over the software, in assemblies, all over. Control and drag is kind of our standard for copy. But one of the things that you can actually do with that is if you control and drag this, but release control before I drop this, so I've got my finger off the control key now, I still have a preview, and when I let go of this, it actually moves my whole sketch. So rather than duplicate it, it slides it over. And I think that's kind of a cool one. I think actually Lars told me that one too. It's kind of a neat one. I've used it a ton of times since. It's just kind of a handy shortcut. The cool thing is we can actually drag and drop this onto a point that we're aiming for. So release my shortcut key. And the cool thing about it is, check that out. I've got an auto relation that's about to drop. So it actually puts a relation in, which is really nice. I think move entities will allow you to do from 2 points, but it won't. Yeah, it'll put it there, but it won't hold it there. And the neat thing about the control, drag and release control, is that it's quick. It's right. Your fingertips are already right there. So you can do that with no problem, and it adds the relation in. Again, if I just undo that real quick, with move entities, we've of course got the from to, so we can say from here to here, and that does the same thing. But notice no relation shows up, so I can still move that point off of where I had it. So that's really nice. Sometimes it is a little bit of a struggle to kind of shift things around when you've got things not fully defined or you're in the process of defining things. You just need to move a whole group. Of course, blocks are always an option too, but this is kind of a nice one that you can just keep the sketch where it is, just throw everything off to the side or shift things around and be able to place it actually right where you want it and get the result that you're looking for just by releasing before you drop. So that was one that I hadn't known until Lars introduced me to a while back, and I've used it a ton of times since. But it's kind of an obscure one, I guess. So
yeah,
kind of a neat tip.
I got a question about how you selected your Christmas tree to make that happen. It's something new, I think, for most of our
users. So that is some new functionality in 2014. Now with the right click, you've got the option to toggle between box and lasso. I was actually wondering if anybody was going to pick up on that. So we can of course use our box select like we've always been able to. New functionality for 2014 is the lasso selection. So that's kind of neat. The lasso selection is also neat because it works the same way the box does. So we can see if I go one way versus another way, it will pick up just like the box select. So it's either fully contained or just what it touches. Excellent. Neat tool. So that was a twofer, I guess.
Very good. All right. So on my side, I'm going to talk a little bit about bill of materials. And I think these are good tips simply because I think our customers struggle a little bit with formatting of bill of materials.
Yeah.
I think when you insert a bill of materials, whatever's saved in your template, it's just kind of where they leave it, and,
sure.
and they don't know how much control they really have over a bill of materials.
Yeah.
The first thing I want to talk about is just throwing balloons on here. I'm just going to throw a balloon on this page. You can see item 1 matches what we have on the bill of materials. But what if I have a multi-sheet drawing and I decide I want to add a balloon on the other sheet, and that balloon is tied again to the same component within that? You can see that it does tie to that component number. But there's a very specific reason it does that, and I'm not sure people understand when it doesn't work. If you actually go to the properties of the view, there's an option in the properties to make sure that balloon or any balloons in this particular view are linked to a particular table, which if they had multiple tables or sub-assemblies detailed out on other pages, you can link those to multiple bill of materials. I think that's something maybe you weren't aware of as far as control. The rest of the control really comes down to the bill of material table. SOLIDWORKS, when they went away from Excel, seems like forever ago now, have been incorporating a lot of little tips and tricks and details into the bill of material, and I just want to point some of those out. This little icon here, I guess I'll call it, that flies out your bill of materials, shows a couple things. First of all, it shows any components that have already been ballooned on any of the sheets, which is a great way to see how far you've come. But the rest of the functionality you'll find is on the right-click menu, depending on where you right-click. Now, I find users just aren't aware of that this stuff exists. If I right-click on the row header here, I get a completely different set of functionality than if I right-click on a physical component in the bill of materials. The ones that I want to show here are listed at the bottom. The first one is exclude from BOM. We mentioned that a little bit earlier with the assembly visualization. If I exclude it from the BOM, it disappears here, but how do I know which ones I've excluded? It's a very easy way to remove things from your component tree that might have been modeled in SOLIDWORKS but you don't want on the bill of material. Also under the component options, this is, since I right-clicked on a subassembly, I kind of have some other options in here. First of all, where am I getting the part number for this particular component? Remember, sometimes we store it as the configuration name, part number. We have different places to put part number.
Yeah.
So here we can still have that unified column and get that information. But the child components, whether I want to show all the components in the subassembly or I just want to list a single part number here, I can actually hide those and they will no longer show in the bill of materials. And it's a great way to do that. Another thing that I like to do in here is the ability to promote components. So you don't want this to show as a subassembly, but you want all the components on the lower level to move up one. I could go ahead and promote those and move those up a level. Now, beyond that, you're really promoting and demoting components. I have the ability just to grab a component in here and reorder it just by dragging and dropping. That's most people probably are aware of that. But I can also drag a component into a subassembly and actually place it as if it was modeled part of the subassembly. You know, it just shows you that you've done some reorganization in the bill of materials. But I think you know, getting into this stuff will help people be able to create a bill of materials that's accurate enough to take that data out as a CSV and take it into another business system or utilize it a little bit better. I think right now, with all the tools being a little bit scattered and hard to find, it makes it a little bit harder. So that's my tip.
Yeah, that's a good one.
For the
that's
day.
A good one. The BUM, it seems like over the years they just keep adding more and more and more and more tools to the BUM, which is cool because it just keeps filling out to get more and more functionality, more and more control, like you said, which is nice.
Excellent.
Cool. All right, so we have moved on from tips and tricks onto our product spotlight, if you will. So we mentioned at the beginning just a couple of things that Kevin and I saw as we're, over the past few months or whatever, that we thought were kind of cool products that we decided to share with you today. So we've got a handful of them, and the first one that I'll talk about that I kind of thought was neat was this occipital structure sensor. And the way that it works is it plugs into your iPad. So you've got essentially a 3D scanner with you wherever you go, which is pretty cool. It's actually made by the same group that worked on the Xbox Kinect system, which is kind of cool. So they kind of move. I mean, the Xbox Kinect has kind of been the open source preference. We've seen that sensor show up on all sorts of flying robots and all sorts of stuff these days. So again, this is pertinent to what we do because a lot of times scans, where the technology is right now, it's not really good enough to do a whole lot with it other than just a visual representation. But I'm kind of bringing this up because these things are just improving and improving, day in, day out, and it could be a very helpful part of the engineering process for sure. So this one plugs right into your iPad, so you've always got it with you. The image on the bottom right there, you can see the guy's just kind of scanning a room, and just kind of, he takes a swoop around the room, and then he gets all the dimensions for the room, and he can, plan out a floor plan or whatever the case may be. But you can also use this to pull in models that maybe you want to model around. There's something that you're designing around, you can scan this in quick and then design around it, right? So the same way that a 3D scanner typically works these days, but just another kind of step up the ladder in technology for that scanning, and like I said, the algorithms and the technology just keep getting better and better and smaller. So that's definitely going to be an exciting part of the business as that keeps going. I think the industry will definitely kind of fill in around that. The other cool thing with this is, so it's designed to work with the iPad, but it's designed to be as open source as humanly possible. So you can download, they've got everything for it. You can download all the codes for it. You can write your own code for it. They've built it so that you can just plug and play, use it, or you can do as much customization as you want with it, so you can use it exactly how you want to use it, for whatever point use you have for it. So pretty cool little product that I stumbled upon and I wanted to share.
Seems like there's a lot of uses to be able to see the environment where a lot of products are going.
Sure.
With the e-drawings.
Yep,
and the iPad,
augmented reality, yeah, absolutely.
That's phenomenal.
Yep. Scan a room, build your machine, stick your assembly in there, and see where it fits, right? Yeah.
Absolutely. So I kind of stuck to the software side of things a little bit. We're used to the ways that we can find data currently, and we're kind of restricted. In Windows, we can sort by file name, and in some files, we can add a description and add some other things too to search on. If I go to a PDM system like Enterprise, I get a lot more capability and a lot more metadata I can search on, and that's fantastic. I can find a lot of things, but I think one of the struggles with our customer base now is they have a lot of duplicate data. They create a lot of similar parts. They have trouble finding what they've done because it's a different part number. They're not aware. Somebody downloaded a file that they put in there. It's a purchase part. Nobody can find that it's even existing. So what if you could design a part or design a part of a part, a small feature, and search on that feature geometrically to find something similar that you've already done.
Right, kind of like a Google image search, but in 3D.
Right, exactly. Looking at the 3D signature of what can happen. There's a product for that. It's called 3D Part Finder, and that's what I have here today. 3D Part Finder for SOLIDWORKS runs inside of SOLIDWORKS, although there is a version for non-SOLIDWORKS users that will actually search CAD data and present them with the top front right isometric view to compare the various results. But you present it with a default part you're looking for something similar of. You can actually model a simplified version of this. It doesn't even have to be exactly what you're looking for. A couple of cylinder extrudes that meet up, something similar to that. And it runs inside of SOLIDWORKS, and we're able to specify the similarity index between results. This is just more of a number that tells it how different the components can be and how many I'm looking to search for. Do I want to consider mirror parts as identical parts? Because one of the problems is you get duplicates, right?
Yeah.
Well, if I can search my entire base and find out how many duplicates I have, how phenomenal would that be? Now, in just a few moments, I went through my entire database of components. Any components that are exactly the same will show up in the color showing me that it's a duplicate copy. If it's a mirrored component, it will show up in green to let me know it's mirrored. But as you move away from this component to the right, it's further away geometrically. It has enough of a geometric signature to understand that. So the closest they are to the original, the closer they are. And now I can choose, hey, you know what? This is the design I was really looking for. So why don't you show me everything closest to this one? And you'll notice that as I work my way through this, it's now found that there was a duplicate on that one, and it's found the next series that is closest geometrically. It just opens up a whole different world as far as how we find data. There's also an analytics portion to this, because I think in some of our customers the problem is already there. They've created years worth of duplicates and copies.
Legacy data.
This, once it indexes the file base, can tell you how many duplicates you have, how many files are close to the original file. It can tell you how many files of a particular extension.
Wow.
So there's an analytics piece to this. It's just a phenomenal tool, and I think something that all of our customers can take advantage of.
That's a neat one. That's a very neat one. That's another one of those things, right, with algorithms just getting better and better. For the 3D scanner, for the software side too. I have no concept of how you would go about programming that, but that's amazing.
Right.
It's very cool. Cool. So we're going to switch back to me for another product spotlight. And Kevin, I'm a bit of a car guy, so you stick a couple car guys in a garage, and it's all just shop talk, right? It's just hardware. And cars, you've got a lot of cool hardware to talk about. You've got cams and injectors and nitrous and turbos, all sorts of cool stuff. But sometimes in CAD jockeys, all we've got is just all imaginary, it's just stuck in our machine, right? So one of the ones that I wanted to bring up is a cool piece of hardware that kind of deals with what we do as CAD people. And that's really kind of our tool of the trade, right? Our mouse is kind of how we do our work. And I stumbled upon this mouse that I thought was really cool, and it kind of merges two of my passions together. So this mouse was actually designed by BMW, or in conjunction with BMW. This company, Thermaltake, designed this with BMW. And it's a really neat mouse, and there's a couple of cool features that I liked about it. One is the really high resolution laser on the bottom. So you can see 8,200 DPI laser for really nice, smooth, and precise movements on a pixel by pixel basis, practically. Yeah. The other thing that I liked about it was it's adjustable. So the top plates can come up, they can come down. You can adjust the angle of them. Sometimes using a mouse all day long, every day, there's a ton of different ergo mouses out there. I like that this one is kind of adjustable, so you can sort of fit it to your hand because we're just using them all day, every day, like I said. One of the other things that I liked about it, was the programmable keys. So there's a combination of 11 keys that you can program on this. Lots of mouses have programmable keys, but this has quite a few of them. And programmable keys can be really helpful in SolidWorks. Think of hitting a button and just showing or hiding all of your planes or something like that. You can set up a lot of shortcuts that can really save you a lot of time.
Turning on assembly visualization.
Right, exactly. Yeah, you can do whatever with it that you like, and you can set it. It's got like 5 different modes or something like that that you can run for different programs. And I thought it was a cool piece of hardware, kind of that goes with our system. A lot of times it's just all in the virtual world, and so we send it to the Stratasys machine and get a 3D printed or run CamWorks on it and get our machine part. But this is kind of a cool one that gets overlooked a lot. You kind of just use the mouse and don't really think about it. So I'm kind of a hardware guy, so I thought that was a cool piece of hardware that kind of deals with what we do on a day-to-day basis.
Hand cooling even.
Yeah, hand cooling. It's got the little hole so it cools and grips, and that's pretty neat. I think I might pick one up. They're not crazy expensive. I think they're about $65 or so, so they're not crazy, but it looks pretty neat. Yeah. You can have it light up 7 different colors, and it's cool.
Wow, very nice. Looking through to finish off, I think we got just a few questions here, and we have a question about whether or not we've used some of the occipital sensor tools.
Yeah, no, I have not. I don't even think it's actually out yet. They had a Kickstarter a little while back. I'm not even sure it's in production yet. I'd have to check, but I know they were working towards it. I haven't used it yet. That was not crazy expensive either. I think it was $350, I think, for the sensor, which is not too bad. I mean, when you consider some of the other 3D scanning options.
Do you know if it will be able to scan a part, like for reverse engineering?
Yeah. So I don't know what the algorithm is, in terms of getting it from the scanner to SolidWorks. I don't know what file formats it uses or anything like that. But it definitely, they were showing, scanning in a bust model, and it looked pretty cool, but I don't know, file formats. Of course, it's open source, so if you're able to program, I'm sure you can figure out a bridge in there somewhere. But it looked like a really neat system. It was able to figure out distances because of the way that it uses the same kind of connect. It uses all those point data to measure distances. So pretty neat tool for the price anyway. Definitely interested to check it out.
Did they have any costs maybe associated?
It was $350. So it's not bad at all. It's a neat system.
All right. Any more questions here? I think we're wrapping up our second morning show.
Yeah.
I think it was a lot of cool stuff.
Yeah, I had fun. Hopefully you guys had some fun too.
So I guess our next one is in January.
Yeah.
We'll have 2 more hosts. Not sure it will be me and Jesse. It will be probably some more of our staff. But
I think there's a lot of people jabbing us out of the way so they can get in. So
absolutely. Everyone have an awesome Christmas, safe holiday, and we'll see you next month.
Thanks, guys.